The year is 2025. Mount St. Helens, a name etched in the annals of volcanic history, is once again making its presence felt. Deep beneath the serene beauty of the Pacific Northwest, the earth whispers. These whispers, though faint, are growing louder, hinting at the restless nature of the ground beneath. Mount St. Helens, a name synonymous with volcanic fury, has begun to tremble. The mountain, which once unleashed its wrath in 1980, is now showing signs of stirring from its slumber. A series of small earthquakes, barely perceptible to those living nearby, ripple through the earth. These tremors, though minor, are significant indicators of the mountain's awakening. These tremors, however, are a stark reminder: the earth is alive, a dynamic force with the potential for both creation and destruction. The steam vents and the occasional lava flow from past eruptions are testament to this dual nature. These recent events at Mount St. Helens have sent ripples of concern through the scientific community. Geologists and volcanologists are closely monitoring the situation, analyzing data, and preparing for any eventuality. While not an eruption in itself, this uptick in seismic activity serves as a potent reminder of the raw power that lies dormant beneath the surface. The crater, the volcanic rocks, and the steam vents all tell a story of a mountain that is very much alive. The question arises, is this activity isolated, or could it be a harbinger of something more significant brewing beneath the surface of the American West? As scientists continue their vigilant watch, the world waits with bated breath, aware that the forces of nature are beyond human control, and the next chapter in Mount St. Helens' story is yet to be written. Hundreds of miles to the east, beneath the geothermal wonders of Yellowstone National Park, lies another giant. The Yellowstone supervolcano, a slumbering behemoth capable of eruptions thousands of times more powerful than Mount St. Helens, captures the imagination and stirs primal fear in equal measure. While geographically separated, Mount St. Helens and Yellowstone are linked by a network of fault lines and magma chambers that snake beneath the Earth's crust. The recent tremors at Mount St. Helens have raised a crucial question. Could this activity trigger a chain reaction, potentially impacting the Yellowstone supervolcano? While the possibility is remote, the interconnected nature of these geological giants means that scientists cannot dismiss the possibility entirely. Understanding the relationship between these two volcanic systems is crucial in assessing any potential risk. One of the most closely watched indicators of volcanic activity is ground uplift. Imagine the Earth as a giant lung, expanding and contracting with each breath. Similarly, the ground surface above a magma chamber can rise and fall as magma moves and pressure builds beneath the surface. This subtle movement, often measured in mere centimeters, can be a telltale sign of impending volcanic activity. In recent years, scientists have observed a gradual but persistent pattern of ground uplift at Yellowstone. While not yet at alarming levels, this uplift, coupled with the recent tremors at Mount St. Helens, has intensified the scrutiny on this geologically active region. The Earth is speaking to us through these subtle movements, and understanding their language is paramount. Section 4. Echoes of the Past. Yellowstone's Fiery History. To comprehend the potential risks posed by Yellowstone, we must delve into its fiery past. This region is not just a serene landscape of geysers and hot springs, it is a ticking geological time bomb with a history of cataclysmic events. The Yellowstone supervolcano has experienced 3 cataclysmic eruptions in the last 2.1 million years, each one dwarfing anything witnessed in human history. These eruptions were so massive that they altered the global climate and reshaped entire ecosystems. These eruptions, spaced roughly 600,000 years apart, have reshaped the landscape of North America, leaving behind vast calderas and blanketing the continent in ash. The sheer scale of these events is almost unimaginable, with ash clouds that could have circled the globe. While the last super-eruption occurred over 640,000 years ago, the geological clock keeps ticking. Scientists use this clock to understand the cycles of volcanic activity and to predict future eruptions. The recent uptick in seismic activity, coupled with the ongoing ground uplift, serves as a stark reminder that Yellowstone's volcanic story is far from over. These signs indicate that magma is still moving beneath the surface, keeping the potential for future eruptions alive. By studying the past, we gain valuable insights into the potential future of this volatile region. Understanding Yellowstone's fiery history helps scientists develop better monitoring systems and prepare for the possibility of another super eruption, ensuring that we are not caught off guard by nature's immense power. Section 5. Sentinels of Stone Monitoring a Restless Giant. Given the potential consequences of a Yellowstone eruption, scientists maintain a vigilant watch over this geological giant. A sophisticated network of seismometers, GPS stations, and gas monitoring equipment constantly tracks the pulse of the Earth beneath Yellowstone. These instruments provide a stream of data, allowing scientists to detect even the slightest changes in seismic activity, ground deformation, and gas emissions. The data collected from these monitoring stations helps scientists understand the complex interplay of forces at work beneath Yellowstone. By analyzing patterns and trends, scientists can better assess the likelihood of an eruption and provide timely warnings should the need arise. The watchful eyes of science are constantly on guard, seeking to unravel the mysteries of Yellowstone's fiery heart. Section 6: The future unfolds. Potential scenarios and preparedness. While the likelihood of a Yellowstone super-eruption in our lifetime remains statistically low, the potential consequences of such an event are so significant that they simply cannot be ignored. Scientists continue to refine their models and simulations, exploring a wide range of possible eruption scenarios and their potential impact on the surrounding environment, climate, and human civilization as a whole. Understanding the potential risks allows for better preparedness and response strategies. Emergency response plans, evacuation routes, and public education campaigns are all crucial components of mitigating the impact of any future volcanic event, whether it be a minor eruption or a full-scale super-eruption. Knowledge is power, and by understanding the risks, we can better prepare for the uncertainties that lie ahead. Section 7: The Unending Watch. A legacy of vigilance. The Earth, in its vastness and complexity, continues to hold many secrets. From the depths of its oceans to the peaks of its mountains, our planet is a living, breathing entity, constantly evolving and reshaping itself. The study of these changes is not just a scientific endeavor but a journey into the very heart of nature's mysteries. Yellowstone, with its fiery heart and unpredictable nature, serves as a constant reminder of the immense power that lies beneath our feet. The geysers that erupt with such force and the hot springs that bubble with life are but surface manifestations of the colossal energy stored within the Earth. This energy, while awe-inspiring, also poses significant risks, making the study and monitoring of such areas crucial for our safety and understanding. The recent tremors at Mount St. Helens, while concerning, also highlight the interconnectedness of our planet and the importance of scientific inquiry. These seismic activities are not isolated events, but part of a larger, intricate web of geological processes. By studying these tremors, scientists can gain insights into the Earth's inner workings, potentially predicting future events and mitigating their impacts. As we stand at the precipice of the unknown, one thing is certain: the quest to understand our planet, its dynamic systems, and the forces that shape it is an ongoing journey. This journey is not just about observation, but also about interpretation and application. The data collected by researchers in the field is meticulously analyzed, leading to new theories and models that enhance our comprehension of Earth's behavior. The legacy of scientific inquiry, fueled by curiosity and a desire to protect our planet and its inhabitants, will continue to guide us as we navigate the uncertainties of the future. This legacy is built on the shoulders of countless researchers who have dedicated their lives to unraveling the mysteries of our world. Their work not only advances our knowledge but also ensures that we are better prepared for the challenges that lie ahead. The watch continues, a testament to human ingenuity and our enduring fascination with the awe-inspiring power of the natural world. As technology advances, so too does our ability to monitor and understand these natural phenomena. The tools and techniques developed today will pave the way for future discoveries, ensuring that the legacy of vigilance and exploration endures for generations to come.